Structure detection. Canny Edges expose object outlines quickly and cheaply. Adaptive thresholding adjusts to local brightness. It's a lightweight way to locate meaningful objects in dull scenes. This demo runs directly on Android. Camera feeds on Android aren't ready for AI out of the box. They flicker, saturate, and drop quality under uneven light. In this video, we'll use 4 simple OpenCV pre-processing steps running live inside a Kivy plus Python for Android app to make your feed stable and AI ready. Frames arrive from the Kivy camera in RGBA format, flow into OpenCV for pre-processing, and then render right back into the app texture. We'll toggle between 4 real-time effects and watch how each transforms the feed for vision and AI work. All steps run live on device. We are optimizing for reliability and clarity over raw frames per second or FPS. If performance dips, disable the texture preview and run analysis only mode. The goal, steady, repeatable pre-processing so your models see clean data. First, tame uneven lighting. Convert to grayscale, then apply CLAHE, contrast limited adaptive histogram equalization. It locally balances light and dark regions and keeps details intact. OCR, barcode, or contour detection all benefit from this stability. Next, structure detection. Canny Edges expose object outlines quickly and cheaply, perfect for debugging frame quality or finding regions of interest without heavy computation. Adaptive thresholding adjusts to local brightness, so even if your light changes, segmentation stays consistent. Then a short morphological open removes tiny speckles, giving you clean, connected masks that downstream algorithms can trust. When color cues matter, switch to HSV. We isolate hue and brightness to detect target colors, yellow, red, blue, or green, and track the largest contour. If no color stands out, the fallback finds dark or bright regions automatically. It's a way to locate meaningful objects in dull scenes. With these 4 preprocessors running, performance holds as long as you're smart about data flow. Downscale before heavy ops. Reuse NumPy arrays instead of reallocating each frame. Limit color conversions and avoid multiple GPU to CPU copies. Grayscale and Edges are fastest, Adaptive and HSV add cost but bring stability. These 4 steps look simple, but they are the hidden layer between a noisy camera and a usable data set. Consistent contrast, structure, and masks mean any model, local or cloud, receives predictable input and gives your AI a fighting chance. From here, you can build your own path. These 4 filters form the backbone of reliable Android vision pipelines. If your Kivy plus OpenCV app already handles them smoothly, you have solved the hardest part of making Android vision behave. Rather skip the plumbing and start from a working foundation, my premium Kivy plus OpenCV build already does this. A fully functional camera pipeline ready for vision and AI pre-processing. This video showed you why it matters. That build gives you how it's done, ready to deploy and extend.